All right, let's talk about another way that we're going to measure angles. We've already talked about degrees, and degrees is the amount of rotation from your initial ray to your terminal ray, either clockwise or counterclockwise. Another way we're going to measure an angle is going to be based off of distance. So in this case, we're going to start going with the circle. We're going to be working with circles a lot in trigonometry. And one of the first things you learn about a circle is the radius. And we know that the radius is the same all the way around. So both of those being radiuses or radii means that they're going to be the same length. Well, we have a way we could actually define the arc length. Let's say this arc length right here, which is going to be subtended by this central angle, let's call this theta, that this length right here, if that is also r, that is actually a radian. A radian is exactly one radius picked up and bent around the arc length. So what you really need to understand is that one radius equals one radian. Now, conveniently, all the way around the circle, there is exactly 2 pi radians all the way around the circle, regardless of the start size, where it's 2 pi radiuses. It'll take about 6.28 radiuses to get all the way around any circle, regardless of the size. All right, so let's talk about how we can convert between radians and degrees and radians by using a basic conversion factor that you have been using. All right, let's do some conversions. First thing we need is a conversion factor from degrees to radians and radians to degrees. I know one full rotation is 360 degrees. I also know it's going to take 2 pi radians to get all the way around a circle. Now in math, you're allowed to add 0 or multiply by 1 and it doesn't change a number. So I'm going to use this conversion factor to create the number 1 in 2 different ways. The first thing I want to do is I want to do 360 degrees over 2 pi. I'm going to divide both sides by 2 pi. And I want to simplify the fraction. I got 1 equals, because 2 pi divided by 2 pi is 1, 180 degrees over pi. I can do the same thing, 360 degrees equals 2 pi, but I'm going to divide by 360 degrees on both sides. You notice 360 divided by 360 gives me 1, and this gives me pi over 180 degrees. Now you notice both of these equal 1, and I'll show you why here in a second, why that's important. Because we're converting from degrees to radians and radians to degrees. So this one right here is going to be from radians to degrees, and this one is from degrees to radians. The way I always remember it is if my pi is on the bottom, it means I have a radian, and I'm going to convert to degrees. If I have a degree on bottom, I have a degree, I'm going to convert to radian. All right, so let's look at an example. Let's say I have 13 pi over 12. This is a radian, and I want it in degrees. Well, I can't change this number. Well, I know I'm allowed to multiply by 1, and it wouldn't change the number, but I'm going to multiply by this one right here. So I'm going to do times 180 degrees over pi. Well, my pi's cancel out. Let's see, 12 goes into 180 15 times. Don't forget your degree symbol. And then 15 times 13, it should be 195 degrees. Should be 195 degrees, which it is. All right, so that's how you would convert from radians to degrees. If I want to do degrees to radians, I can just pick a degree. Let's say 375 degrees. I want to convert 375 degrees to radians. Well, here I have a degree. I'm going to radians. I'm just simply going to do pi over 180. It means I'm multiplying it by 1, which doesn't change the number. Pi over 180. Once we do all of this math, we're going to get 23 pi over 12. So 23 pi over 12 is the same thing as 375 degrees. But degrees, this is a rotation, this is a distance. You have to know the difference. You're rotating 375 degrees counterclockwise. you have traveled 23 pi divided by 12 radiuses around that circle. So this is a distance, this is a rotation. You have to know the difference. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.